One important thing, and I believe it's the most important thing of section 1A. Hello everyone, I'm a structural engineer working in the UK for over a decade now, designing buildings, and I passed my IStructE exam a few years ago. So in this video I will go through section 1A of the 2024 July exam. My aim is to let you know the main reasons why people fail this section, so that can give you an idea of why people fail and you can avoid those issues. Some tips so you can go through this section faster, though this is the most important section of the exam, so it's the one that you will want to spend the longest. So the first thing I do is I write, again, even though they're written in the exam question, I write the client requirements in the exam, and then I start basically commenting on these requirements and what that will mean for the design of the building. For example, in this case, cladding is going to be masonry, and 25% of the elevation needs to be windows, and if there's any bracing, then it has to be not visible. What that means is that it will need to be behind the masonry. Once I go through the column arrangements and the main client requirements, then I start writing the main difficulties that I identify in this section based on the client requirements and constraints. So for this example was that, well, there's no internal columns at the lecture theater. That means that there's going to likely be very long spans in that section. There's no bracings at the perimeters, and I think this is an error that I corrected later. There can be bracings at the perimeter, but they have to be non-visible, so they have to be behind masonry, not in the glazed area. There's a reduced number of columns allowed for the plant room area, which means either you might require a transfer structure or, again, very long spans if you decide not to use transfer structures. Once I have the main difficulties written down, then the next thing is trying to prepare a column arrangement. This is before I start doing the two options. I write what the column arrangement or a typical column arrangement will be based on the constraints in the client requirements. I liked it when I was practicing my exam to have an idea, just a very rough idea of where, based on these constraints, where are my columns going to go, so that I had an idea of what would be the best way to support the structure, from the top, from below, from the sides, etc. So now I realized that I had made a mistake, because there's no constraint of not having bracing at the perimeter, but they have to be non-visible. So I had to update that on the first part of the section. Then this is a very important tip I used during the exam, a erasable pen, because I made a lot of mistakes during the exam and had to correct them. Once I was doing the drawings, I realized, oh, I missed this part in here in the section 1A, so I came back to section 1A to correct them. Once I have the column arrangement, then I start preparing the construction zones. Basically, this is based on the client requirements. I start to define what's the depth that I have allowed for each level to put my structure, my floor and my beams. So I'll draw an elevation or a section, cross-section, and then follow the client requirements on what's the ceiling height required, if there's any M&E depth required, and then the remaining between the expected floor level and the floor level above. Then that's the area that is called construction zones, where I can put my structure, my beams, and my floor. After that, then I go to the foundations. And for that, I like to show basically a representation of the borehole information that we have, so that you can see a cross-section of approximately what the soil are going to look like in the building. And then I give a small short explanation of what that means for our foundations in this building. So basically on the information that we have, I mentioned the type of foundation, which is, well, it could be a shallow foundation if we go down to the stiff clay, or deep foundations if we go down to the rock level. The ground level slab can be ground bearing because the top level it's soft clay, which has some adequate capacity for the ground bearing slab. I started by thinking that it would be a good idea that the first scheme was going to be steel, and I changed my mind later, as you will see. So to show the scheme, I draw normally 2 plans and maybe 2 sections, or 1 elevation and 1 section. You could have, if you wanted to, you could have at level 1 a different column arrangement because you got more freedom, you don't have the lecture theater, but I wanted to avoid having transfer structures, at least for the option that I wanted to go for. And the other part is level 4. Level 4 is the plant room, and you have a limited number of columns that you can put within the plant room. I think it was 6 of them. And I start drawing some beams directions, mainly for me and to show the examiner what it is that I am planning to do. So you can see that I show where the normal spans of 6 meters are in my grid, and then wherever I have larger spans, there are 9 meter spans, 12 meter span, and even is a 21 meter span at the roof or above level 4 because of the limited number of columns. Now here is where I notice the column arrangement that I was drawing, especially with those internal roof columns in the plant room, would be better to have them as a concrete structure, because everything or all the vertical structure that I was adding in here, basically the columns, they were all under compression. And what that means is it's ideal to have concrete under compression. And then I came up with the idea while I was drawing these internal columns in the plant room of having an option with no columns at all in the plant room, which, well, it gives a lot of flexibility. It also means possibly less material, depending on, well, how do you solve the issue of not having columns at the plan room. And that's why I decided to change the scheme 1 for a concrete scheme, and then scheme 2 for a steel scheme. I also started to write when I come up with the positives and negatives of each scheme on one side, so that I can, well, I don't have to remember them. I just go back and read them and put them in when I am choosing which scheme is better. Well, I already have written down what the pros and cons of each one is. One important thing, and I believe it's the most important thing of section 1A, is to make sure that both of your schemes are very different. And the reason that you make sure that they are really different, that there's no way that they can be taken as two very similar schemes but just changing the material, in my opinion, and this is what I've done in my exam and make sure that I did during my preparation, it was that you always have 3 different things between your first scheme and your second scheme. And those 3 different things are the material, the column arrangement, and the load path. If you have the material, the column arrangement, and the load path different in the scheme 1 and in the scheme 2, they are going to be 2 absolutely different schemes. What tends to happen based on the previous exams is that a lot of people basically give 2 schemes quite similar and they only change the material and maybe a few column arrangements. But the moment that you change your load path, that means that basically in one option is supported all in gravity and the other one maybe with some tension elements or some cantilever elements, then that changes your scheme 1 or your scheme 2. It makes them very different. And that's, to me, the key, to make sure that you have those 3 things different between scheme 1 and scheme 2. Different material, different column arrangement, and different load path. You have to show how your building receives lateral loads, basically stability, and what's the load path or how your structure transfers the loads. In this case, the load path is all downwards. Vertical is just, well, I show in a scheme very quickly. The vertical loads go to the beam, to the slab, then to the beam, then to the columns, down to the foundations, and from the foundations to the soil. And let's same or similar for the lateral stability. So when you go wind loads, in this case, because it's a concrete structure, we got shear walls that are going to be resisting the wind loads. And then I like to show more or less what would be the behavior of the shear wall. And then I put a very simplified bending moment diagram of the shear walls, which is basically a cantilever column or wall with lateral loads, and I showed the bending moment diagram in my exam. Once I have all of that, which is normally 2 plan views showing the different column arrangements at different levels, and 2 sections or 1 section in 1 elevation showing load transfer and also lateral stability, I can go to the next scheme or the next option. For the level 4 to the roof, I changed the column arrangement for the scheme 2. So scheme 1, columns in every level, concrete, and mainly structures in compression on the gravity loads. Scheme 2, then I decided what would be a main difference in the column arrangement. Let's have no column in the plan room. So that's already a column arrangement difference. Then the next thing is a scheme 2 is going to be steel, so I am already changing the material there. And then 3 is the load path. In scheme 2, because I'm not going to have columns in plan 2, in the plan room level, then I decided I'm going to use trusses for the roof. And you will see in my other videos, I tend to go for trusses whenever there's a steel solution. So once I draw the columns and the beams in the plan view, I go to the cross section, and I need to make sure that I emphasize here in the cross section the main difference, that is no columns, plan room, and trusses. So I need to draw my trusses that are visible. So my section, at least one of the sections that I choose, needs to show longitudinally the trusses, because it's going to be one of the key elements that we'll have to design later. Now, I just wrote personal notes, and it's basically I use to my advantage the fact that there's no limit on the top level or the highest level of the building. So long as your levels for the floor are as the client requirement design constraint impose, then the roof or the trusses on the roof can be as tall as they need to be. Whenever I have a truss, then I tend to show the load path, showing what parts of the truss are going to be in compression and what parts are going to be in tension, and in this case, which parts are not going to take any load. And you'll see that I noticed that one of the nodes, it just didn't make sense, it wasn't in equilibrium. So by the end, I changed it because I show two of the diagonals in tension. They shouldn't be in tension in this case, so I changed it later for them to be in compression. So in this exam I went for a Warren truss, which normally I don't go for, but it just came naturally when I was drawing it. But normally I like to go for Pratt trusses, which are way simpler in showing what elements are in compression and what elements are in tension. For the steel structure or scheme 2, then there's not going to be shear walls, and instead there's just going to be some cores where the stairs and the lift are that are going to have vertical bracing. And then it'll be ideal to show how the lateral loads are going to be transferred through the cross bracing. By the end, then once I have to choose the scheme, which is the last part of section 1A, I prepare a small paragraph just explaining a little bit of both scheme. Then I write a list of pros and cons for each scheme. I know which one I'm going to go for. In this case, it's going to be scheme 2. And I write the reasons why I'm going for that scheme by the end. So even though I have all the pros and cons in here, then I write a final paragraph explaining what the benefit of this scheme are and what the cons of this scheme are. And then based on the pros and cons that I wrote in there, scheme 2 is going to be the chosen one. And I explain that the reason is because it's probably going to be a lighter structure. It's going to be faster to build, and I expect less embodied CO2 because of the less cement that is expected to be used for this solution. And that's the end of the exam. What I did in the end was like, well, if I got some extra time during the exam, then I'll go back to section 1A and start checking that everything is correct. In this case, I corrected the diagonals that were shown in tension and should have been in compression. And if there's any additional information, any other sizing or load path that I can show, if I still have time to complete section 1A, then I go back and make sure that I make it look as best as it can be, because this is the most important section of the exam.